Hello everyone and welcome back to Arctic Retro. This is an Amiga 2000 and it is mine, but it is not working. So I got this Amiga 2000 around 1 year ago, and I did some restoration work on it. Actually, I did it on two Amiga 2000s at once. I made a video series about that 1 year ago. You can take a look at that. However, the conclusion was that this machine, which is mine, did not work. There were extensive damage on the motherboard due to battery leakage, and even though I tried to clean up as good as I couldn't get the machine to work. It just starts with a green screen, and I actually tested that both the Agnus chip and the CPU were all good. I did some replacement of the CPU socket and the recapping, lots of stuff, but still doesn't work. So I kind of gave up on that machine then, and now I thought it's time to actually take another look at it, go a little bit more detailed to work and actually see if I can figure out what's wrong with it and fix it. So if you want to see the videos where I restored two Amiga 2000s, just go to my channel Arctic Retro and search for Amiga 2000, and you should find 4 videos. This video is sponsored by PCBWay, and if you need to have produced some PCBs yourself, like I do regularly, then you should visit the PCBWay.com. If you visit PCBWay.com, you can get an instant quote on very good quality PCBs for affordable prices. And if you have advanced needs for PCB manufacturing, then check out their advanced PCB options at PCBWay.com. So cosmetically, this machine looks very nice. It is now a little bit dusty after being stored away for a while. I actually made a note here back then what I did. It says here April 2021, that's 1.5 years in fact. I cleaned the machine, mainboard, power supply, floppy, removed rust, recapped the motherboard and the PSU, removed battery and acid damage. The floppy drive works okay, but missing its floppy cable. Motherboard does not start, shows green screen. HD LED, one wire is loose, and the keyboard was cleaned. So I'm simply gonna open up the machine now and take out the motherboard and the power supply, and yeah, let's see if it still behaves the same as it did then. It is kind of huge for my bench. So it has a couple of screws. I think a few of those are missing. So I'm going to take out the screws and then remove the case. So the whole top and the front just slides out like this. Another note, works good. This is a coin cell battery holder with a diode that can be used in an Amiga for replacing the original battery which damaged this machine in the first place. Okay, I'm gonna remove the rest of the stuff here and free up the motherboard, get it out of the case, take out the power supply so that we can use it to power the motherboard without the whole case on the bench. Removing the motherboard is quite easy as well. I think it has a few screws, and yeah, some of those are here in the back. There's one there, but you have these plastic clips around that you need to clip in order for this board to come loose. Actually looks like one of these screws also are screwed to the chassis. Yeah, now it's loose. Okay, it's free. Okay, there you have it, and yeah, the damage I talked about was this area here. As you can see, I have removed some of the old solder mask, and yeah, I cleaned up a lot here because there was a lot of battery damage around this area all the way over here, and yeah, these connectors was green, all these components, so all the caps are new. CPU is working, and I also put new solder mask on top, but what I didn't do was actually to check all the traces to see if they were good, and that is something I'm gonna do now. I'm gonna at least check that all the traces from the CPU socket is going where they're supposed to go, and see if we can find some broken traces or anything that prevents this machine from starting up. I hooked it up to the power supply. It has to sit on top of the contacts there because the wires are too short, but hooked up the TV now. Let's turn it on and see how it reacts. We get a black screen, but that's about it. So before it produced a green screen, but now it is black. So at least there is a video signal. So it's been on for a while, and yeah, there I can feel a little bit heat on the CPU. So there's definitely power to the board. I took a couple of chips in and out. Let's see now if it makes any difference. Yeah, there you go. So that's the green, and yeah, that indicates RAM issues, I think. Before I hook up the oscilloscope and start diagnosing on this board, I'm actually going to do a little bit more testing first. I took out the CPU, and it has a brand new turn pin socket, so I think the socket's alright. The Amiga 2000 board has this dedicated CPU slot. That means you can insert the CPU into this slot instead of the socket, and yeah, I put it into this adapter card here. So just gonna see if that's the same result. Yeah, same, that's green screen. No, just to rule out that it isn't the CPU, at least I'm gonna try and replace the CPU, and I actually got this terrible fire card here, which has a Motorola 68030 CPU and a coprocessor and additional RAM, and the plan was to use this in this machine if I get it to work. So yeah, let's try with this one. And this also has an IDE adapter built in, so we can connect the CF card to this later if I get it to work. That is. Let's try with this one then. Yeah, it's the same. It's green. I guess that means that the code is running and the CPU is running. If I pull out the CPU completely, then it's just going to be a black screen and nothing's happening. So what I'm thinking is the fault here is that the communication between the CPU and the Agnus chip and the RAM. The Agnus chip controls the RAM access and lots of other stuff. I think maybe there's something there. Might be the RAM chips, obviously, could be that. I'm not that familiar with the Amiga architecture. Yeah, how it works. I printed out some pinouts here for the Agnus chip, and also for the CPU. And yeah, I'm gonna start by just probing or checking continuity between the address lines and the data lines, and yeah, see if there's any issues there first. First of all, let's see if we have any 5 volt onto this chip on the socket, and yeah, there's 2 VCCs, pin 14 and 49. So let's count 3, 14. Yeah, there's 5.1 volts, and the 49 is this. Yeah, so there's voltage. Next, I'm gonna check continuity on the data bus and the address bus, and yeah, with all these pins, there's a lot. That's gonna take some time, but I'm just gonna try with one that are easy to find. Let's say address line 4, which is the last pin on this edge, and I already counted. It should be on the Agnus chip, it should be this pin here. Yeah, so there is continuity there. Then if we jump to the next, A3, A2, A1. So A1 through 4 is okay. I'm gonna check all the rest now, and I'll be back after that. Alright, I'm back. I did a lot of continuity checking, and yeah, looking good so far. I checked all the address lines up to A19, which goes from the CPU to the Agnus chip, and they all are alright. Also checked all the data lines going from the CPU to the Kickstart ROM. They are okay. Also checked all the so-called RDR lines, data lines going from the Agnus to the RAM, and they all are fine. So yeah, doesn't look to be any issues so far, and yeah, I'm just gonna check the rest of the lines and see how it goes. Okay, I have done a lot more checking of the lines of the data bus and the address bus. I checked continuity from the CPU up to the CIA chips, up to the bus transceiver chips, and the circuitry around the RAM, and from those to the RAM. Check the lines between the CPU socket and this CPU slot, and check the data lines going to the real-time clock chip, and yeah, also checked some of the lines going under here where the battery damage were, and seems like most of the things going here is related to the circuitry for the real-time clock, and I can't find anything missing. So yeah, I guess then it's time to start scoping and see if the signals from the bus goes correctly to the RAM chips, and if the RAM chips are okay. I haven't checked all the other lines going into the CPU that is not the address and data bus, but yeah, I'm gonna insert the CPU now and start a little bit more diagnosing here, and check as much as I can with the oscilloscope. Obviously, doing this kind of diagnosis is not possible without some good schematics, and I have this revision 6 schematics. My board is a revision 4.4, but yeah, it's more or less the same when it comes to these kinds of things. And yeah, and this is really good schematics. I'm gonna use the picoscope that is based on a PC software, connects to a PC via USB, and that's this one. So there's ground on this capacitor, so yeah, gonna try with the RAM chips first, see if there's activity on the data lines, and yeah, take it from there. This machine has 1 megabyte of RAM, and it has 32 4 256 DRAM chips, and this is the datasheet and the pinouts. First I'm checking that all the chips has VCC or 5 volts. Yeah, that's okay. Perfect 5 volts. Yeah, and they all got 5 volts input, so we're good there. Then I'm gonna check some of the address lines, one line at a time, see if there's activity. So I actually noticed that I found the wrong datasheet. The one I had up before was for a 20 pin chip. This is the actual chip, the TMS 4256, which is a 16 pin chip. So let's see now, pin 5 on the first chip. Yeah, it has some signal. I'm not really sure. I'm going to change the time base here. Yeah, at least there is activity, and okay, I'm gonna go through everything here and check everything out and see if I find something missing then. Actually, before I do that, I'm gonna check that there's activity on all the lines of the address bus out of the CPU. So that's a good idea to check that first, I think. A1, yeah, that's activity. A2, yes. A3, A4. Yes, all the data lines and the address lines out of the CPU seems to have good strong signal and normal activity. I suddenly remember that I have an Amiga diagnostics ROM, and I'm gonna try this. I have never tried and used this before, so I'm not really sure how it's supposed to work and if it works with the Amiga 2000, but still gonna try it, see what happens. Let's see now. Okay, that's colorful. I suppose the colors have some meaning. I need to look up what it actually means. Oh, look at that. Don't know what to make of that. I know that the diagram should present text if it's working, but this might be some routines that runs if it can't actually show any text. So I actually read a little bit documentation for the diagram, and it actually sends data on the serial port as well as displaying on the screen. And I have a null mode and cable here, a little adapter, so I'm gonna try that, see if we get anything from this machine. And I have this USB serial adapter on this Windows machine. So the first thing I'm gonna check is that the COM port and everything is correct. So here we have USB serial COM3, and then I'm gonna use putty. And just gonna set it to serial and COM3. Okay, I'm going to turn on the machine. Okay, yes, there is data. And the RAM test seems like failed. Trying to find some fastmem as no chipmem found. No chipmem detected, no memory found. Halting system, okay. Good to know that. And in the beginning here we see the diagram 1 to 1, testing serial. A couple of tests were okay and some were failed. But then it starts testing different addresses on the RAM and they all failed. Well, that's good to know, but that does not change what I initially thought, that there is a problem with the RAM. Not necessarily the RAM chips themselves, but some of the other chips here. And now I can just remove this again. I'm gonna test with this later if I get this machine up and running. Then it's back to using the scope to try and narrow down where the issue is. Checking all the the different addressing lines for the memory chips. Yeah, and most of the addressing lines looks like this. So there is a signal, and I checked all A6 down through A7 here. Now I'm gonna check A1, 2 and 0. Looks good. Looks good. That looks a little bit weird. That's A0. Doesn't seem to have any valid low transitions. That's A2, and you can see those dips going down to 0 from time to time. But there on A0 you see those looks like some noise, and not going very low, just dips a little bit down to around 4.5 volts, so that does not look alright. It's in fact the same on all the RAM chips, so that does not look right to me. So what is running A0 on these chips? Checked a little bit more. A0 on the RAM chips are connected via this resistor network here to this U540, and that's the 74F244 chip, and it goes out from pin 18. So let's check that one. Pin 18, it's there. Oh yeah, I see the same signal. It's just for the most part steady high. Okay, here we see the RAM, and A0 goes up here and through this resistor network, A0, and then on pin 18 on U540. Checking pin 18. Yeah, and that's the same signal as we saw on the RAM, dipping down a little bit now and then. Maybe that's it. Maybe that's the chip that's faulty. I'm gonna check the other 244 and see if it behaves the same. No, it doesn't. So that looks correct. That's more like it. So, okay. Have we found the culprit? Is it that 244 chip, U540? Gonna see if I find that chip. A 244 is just a bus driver chip, and yeah, it takes whatever comes in and buffers it and sends it out. So actually gonna check the input on I0, see if we have anything there. I mean, if we don't have a signal in, then we won't get the signal out, obviously. But if we do have a signal in but not out, then the chip is faulty. And that's pin 2. That's actually below 2 volts. So that's the input pin for address line 0. Let's check the other chip. That's more correct. It's yeah, looking okay there. Alright, then I need to trace back some more. This is the 244 chip, and we don't have a signal out on pin 18, as I said, and we also don't have a signal in on pin 2, so need to go back here and find where that line is coming from. It might not be the chip after all. Tracing back, I see that the DRA line is coming directly from the Agnes chip, and it's pin 43. So then I'm gonna check that. And that's the output on pin 43 on the Agnes. And as we can see, there is normal activity there. So okay, then we have traced it back. We have a normal signal out on line 0 from Agnes, pin 43. Exactly the same as the other DRA lines. So what does that mean? That tells us that we have perhaps a broken trace between the Agnes chip pin 43 and the 244 chip. And that is some of the things I didn't check before. So all right, let's check if we have some connection between pin 2 on the 244 and pin 43 on the Agnes. Just need to count here, 33, 34. No, there is no continuity between pin 43 and on the Agnes and pin 2 on the 244. Let's try the next one, which should go to pin 4. Yeah. Okay, we have found a broken trace. Okay, but that's actually good. Then this chip is perhaps good then. So now I'm just gonna figure out where that trace goes. Might be that it goes down here and up and yeah, has been destroyed by the battery leakage, but yeah, we'll find out, and then I need to patch that. I moved the board over to my workbench, and that's the chip, the 244 chip, and that's pin 2, so it's not connected on this side. So we definitely need to check out this side, but it is kind of hard to see where that trace goes. It goes over there, seems to go around that resistor there. So I'm gonna check a little bit more and see if I can find any break. This board is huge. Okay, pin 43 on the Agnes chip is this one, and if we follow that, it goes down here and yeah, all the way down here, and I don't know. Now it's starting to close in on that area that was damaged by the battery leakage. So might be that the battery leakage did this. I'm gonna trace it further on and see where it stops. It is kind of hard to trace those thin traces when you have so many in parallel. Yeah, that's the next point, so that's good. Then I'm gonna mark that green. So that's Sevilla for the other side. Then I just need to flip the board, and I usually just hold a finger on the position I'm interested in, and then by lifting it carefully and looking, I can see that the corresponding via is around there, and that's right above that battery damage. So now I can probe between pin 43 on the chip and yeah, I think it's this one. Yeah, so the via there down to the other side is good, but yeah, and over here we can see that the traces does not look particularly good. Now there's a bit of glare, but it's this via here, and that trace just continues over there. I'm gonna zoom in a bit. Yeah, and definitely these traces here look suspicious. You see the colored black many places, many parts of the trace. Doesn't mean that it's corroded away, but it means that there is corrosion at least. So I think this is supposed to go right up here and up to the 244 chip over here. So I think actually the break is between the via here and the actual trace that goes here. I tried to poke through the solder mask, but I get nothing. So I'm gonna try and remove some of the solder mask around here and get a better look. So I got this little grinding tool. I haven't really used it before much, but I think this bit looks like the correct one. Just carefully try and remove only the solder mask and not the metal. So now we have a better look at the trace, and yeah, let's see now if we have a connection there. That's the via, and that's not the trace. Yeah, that's the trace, and it is off. It is off there. I get nothing on the trace that goes from the via. While I'm doing this, I'm gonna remove a bit more just to see if some of the other traces and vias are bad. Yeah, that tool was actually excellent for that job. You see, even though the trace looks like it's completely eaten away under the solder mask, it is still there, and yeah, I think it's just this coloration of the solder mask that makes it appear as it's corroded away, but it's not. Let's check the other vias and traces. Yes, they look good. That one, I don't know where it goes. But this one is our problem. So it looks like the brake is right there. I'm gonna zoom in even more if I can. So there is no continuity between the via and the trace that goes here. But this other looks to be fine. So I'm just gonna try and use a little bit solder here and bridge the gap between, and then we'll see how it turns out. Just checking some of the other stuff here, and all those lines are good from end to end. Yes. Just gonna take that one next as well. A little bit of solder on the tip. Let's check. Nope, still not connected. Try once more. It is kind of small for my site, but yeah. I think that looks better. Yeah. Now we're good. So now we should have reconnected with pin 2. And we have. Nice. Let's check that I didn't short anything here. No, that's fine. And that's fine. Just gonna clean up a little bit of the flux. Time to test. I hooked up the board again. Let's see, did this fix it? Black screen, white screen, and yes! It's fixed. Okay, I'm very happy now. So actually that was a lot of work to figure out, but it's not that hard if you actually have good schematics, and if you can read it, and if you can trace back the signals, and you have an oscilloscope, then it's just a matter of being persistent and systematic, and then try and follow the signals, which I did, and I found the broken trace there. Hopefully it's a good fix now. And the board is working. Very nice. Okay, I'm gonna test a little bit more now. I'm gonna use that diagram and see what it tells us. And if everything turns out to be alright, then I'm gonna put back the machine and try it out with that Terrible Fire card and see if we get some speed out of this. It's about an hour later, and this has been running for over an hour now, and yeah, it seems to be stable. So I'm just gonna turn it off. That fan is quite noisy, and I'm gonna cover up the traces with some new solder mask. And that's of course to protect the copper from starting corroding again. Try not to make it too thick. You never know, I might have to remove this again someday. Now, this stuff doesn't cure by itself. You need to have some UV light. I have a small UV light pen here, and yeah, doesn't need a lot of time, a couple of minutes, depending on how strong the light is. Yeah, it's solid now, kind of, a little bit more. Yeah, that's it. Now I'm gonna take out the Kickstart ROM and try out that diagnostics ROM. So tell me in the comments, did you have an Amiga back in the day, and what did you use it for? Probably games, but what else did you use it for? Oops, green. Okay, there we go. So there's a bit of color flashing, not really sure if that is how it's supposed to be, but yeah, here we go. System info and audio test, memory test, RQCIA test, graphics test, port test, drive test, keyboard test, other test. Let's try 0, but I don't have a keyboard connected. So now I connected the keyboard. Okay, so looks like it's all green here. I don't know the meaning of all this, but yeah. ROM checksum test, green okay, red failed. CPU 68,000, FPU none. Sorry about the squeaking chair. I need to find a new chair, obviously, or lubricate it. Audio test. Play test module. Yeah. Looks alright. I mean, it sounds alright. I don't know if you can hear it, but I hear music. Let's try the simple waveform test. Yeah, channel 1 okay, channel 2 okay, channel 3 okay, channel 4 okay. Memory tests. Okay, there's a lot of memory tests. This is the fast mem. So, number of errors 0. Let me try a complete memory detection. Your CPU does not allow 32-bit addressing skipping. Total amount of memory detected 0 kilobytes. Yeah, chip mem. I know it's testing it. It's come up to 223 kilobytes, 255. Yeah, it went up until 1 megabyte, and everything looks good. So that's amazing that all those 32 memory chips are still working. Testing IRQ levels, and they seem okay. Level 7 will fail unless you press a custom IRQ button. CIA tests. Yeah, all green there. Graphics test. Okay. Looks good. Port test and drive test. You obviously need a drive and probably some testing harness for the ports. Loopback adapter, yeah, obviously to test joystick ports I need to hook up a joystick. I'm gonna do that later. Real-time clock test. So it seems to be OK chipset output, so seems to be working. Obviously without the battery there's it's not gonna keep the time. Scanning 0, 2 and 3 area. Yeah, that was the tests. Everything looks fine and dandy. Nice. But now comes the most important test. Can I run a game from this machine from a floppy? This floppy connector seems to have a broken off pin inside, and looking at the board, it is actually missing a pin. How did that happen? Well, I'm gonna try and connect it anyway. I don't know why it should have broken off, seems a little bit odd. Well, that's some kind of arrangement, isn't it? Let's see now, does this drive work? I have noted on it that it works okay. Okay, I heard a sound from the floppy drive. Yes, yes, it reads. Yeah, look at that. It just reads in and launches north and south. I hooked up a joystick. Yeah, that's the one. So joystick is working. Nice. Running workbench. Yes, that works. Oh well, it had a read error, but I think that disk is a little bit bad. Doing a little bit diagnostics testing here. I'm loading the Amiga test kit, and let's see now. I am gonna test this machine as much as possible to see that it runs stable before I put it back together again. So run a little bit of memory testing here as well. Alright, I think that's enough with the testing. The machine seems to run very stable and very nicely. I'm now gonna remove the original CPU and insert the Terrible Fire, which has a faster CPU. It's a 68030, and it also has a coprocessor, and it has, I think, 8 megabytes of RAM and an IDE connector. So that's quite a powerful and popular expansion. So first gonna turn it on and run the test kit again, see if it detects the memory. Well, it runs at least. Nope, it won't go past that white screen. I don't know why. I need to investigate a little bit more here. So I put the original CPU in that adapter in the CPU slot, and it is actually working. So I don't know why the Terrible Fire doesn't work. I need to check it out. Here's the 3.1 ROM. Let's check with that and see if that makes any difference. So I waited a good while, and it still just shows a black screen, but it's not all black. It's kind of very dark gray, but still doesn't want to work with the TF card. That's a bit strange. You know what? I'm gonna try with diagram and see if it gives any output. Well, it flashes green. Okay, there's text and a lot of colors flashing. Actually, it identified the CPU and the FPU, but got some artifacts on the screen. Yeah, no, I didn't do anything, but it just completely bombed here, so not sure what's going on. And there it just died. But at least that means that the Terrible Fire card is working. However, it's not working in this machine. Yeah, 68030 and the FPU, and something's not right here. So I actually managed to run the system info, but as you can see, not working very well. I don't know what that could be. Alright, just to make sure that this Terrible Fire card is working alright, I'm gonna test it in an Amiga 500. this is made for fitting into an Amiga 500. The Terrible Fire card is working. Let me try that diagram in this machine. Yes, and sure enough, that seems to work better. No glitchy graphics, and the menu presented. I haven't connected a keyboard, but definitely this is working in the Amiga 500. I inserted the 3.1 ROM, and just gonna check if that works in this machine as well. No, it doesn't seem to work with the 3.1 ROM in the Amiga 500. That's kind of strange. Maybe the Terrible Fire card isn't compatible with the Amiga Forever 3.1 ROM. Not really sure. Continuing to rule out any potential compatibility issues, I'm putting in the original 2.0 ROM that was in the Amiga 2000. Okay, now I get the white screen. So that's really strange. I placed back the original CPU, and I'm gonna keep the 2.0 ROM in this Amiga 500 and use the 1.3 in the 2000 for now, until I figure out what's going on here. Back to the 2000, I inserted the 1.3 ROM and the TF card. Let's see if that can play. Okay. Guru Meditation. Haven't seen that for a while. Yeah, with the 1.3 ROM, it actually works with the regular CPU in the... Okay, until I touched it, it's maybe a little wobbly here. Maybe that's the case. Maybe the contact there is not the best. It seems to be stable and working in the CPU slot, so I don't have a clue what's the matter with that Terrible Fire card. It's obviously not just plug and play. Maybe I need to update the firmware on this or something like that. I have no clue. I have Googled a little bit, and I couldn't really find any other that has issues with the Amiga 2000. Saw a couple of YouTube videos where this was used in an Amiga 2000, and they just plugged it in and it worked. So yeah, well, look at that. Terrible Fire card is in. I get the workbench symbol. What did I do? Nothing. I just took it out and set it in a couple of times, but yeah, as you can see. So my conclusion is the Terrible Fire card is not running stable on this machine. The reason for that, I don't know. If you have any clue on what to do to fix this, I'll be glad to hear it in the comments. What I'm gonna do now is to just insert original CPU and the 3.1 ROM, and then I'm gonna assemble this machine. Just have to live without the extra speed and the memory for a while more, I guess. However, I was also planning to using this CF card, yeah, like a hard drive, if I could get this to work, which I don't, so I give up for now. Anyway, this video was about repairing the machine and not actually upgrading it, so that will have to come in another video sometime later, I guess. But I got the 65010 CPU here, so I'm gonna insert that just to have a little bit of upgrade here. In with the 3.1 ROM. Gonna do a little quick diagnostics test before I start putting the machine back together again. Yeah, and it detected the 68010 CPU, so now everything works as it should. Before I assemble the machine, I want to install this battery module, and to replace the leaked one. And it just fits where the old battery terminals were. Another issue I noticed was actually this, the power LED and hard drive module. It has one of the wires has come off, and need to find a way to solder it back. I guess you can maybe open these. Looks like that has been tried before. Yes. Yeah, no, that other one broke off as well. Looks like the LED is glued in place there. I can't get it out. But there is still some metal coming out of the hole. It won't be easy without melting a little bit of plastic, but I'll try to be quick. Yes. Yeah, I think it's solid. I've inserted the battery, but I'm not really sure if it is correctly hooked up. I mean, with all the battery damage that were here, maybe some traces here is broken, but yeah, I'm gonna try and measure. We have 3.3 volts. Now how this is transformed and used by the real-time clock chip, I'm not really sure. Just gonna measure a little bit on this circuitry here. Yeah, there's 3 volts over there, and the chip, yeah, it got 3 volts. So looks like that's working. So I think that's it for this repair, and I'm gonna assemble the machine and then do a final check, and I think we're almost done. Doing a little preliminary testing here. So I'm setting the date and the time to 11. So now I'm gonna boot the machine and see if it sticks. Let's see, did it store the clock? Yes, it did. Nice. But now I noticed another fault. There's no light in the power LED, and I have connected it to the connector. And I am now checking if there's any voltage on the LED connector for the power. And there is 5 volts, but still there is no light in the red LED, so I think that is definitely gone. Green is working, so maybe I just use that for now. I just switched the green to the power, and that's gonna do. I don't have a hard drive yet. And these rectangular LEDs aren't easy to find, I think. I don't have any of those. Now, before I put back the top and the front cover, I just printed this cover here for the CD-ROM bay, or yeah. Obviously not the correct color. I don't have a color that looks like this, but this will do. I am actually planning to see if I can mount a CD-ROM drive into this Amiga at some point, but not now. I found some screws that can fit. The machine has this switch here. I don't know what it was used for, but I'm just gonna leave it there. Alright, I think that was it for this video. I'm really happy that I managed to repair this very nice looking Amiga 2000 machine. Too bad I couldn't get that terrible fire accelerator to work. I need to investigate a little bit more about that. If you have any suggestions, then just give me a message. Yeah, and obviously there's a lot of more you can do with an Amiga 2000, different upgrades. I need to get a hard drive in it, either a CF card or a real hard drive. I'll see about that, but that was so far I took it in this video. Probably gonna make some other videos in the future about this machine, we'll see. Okay, hope you enjoyed the video and that you learned something, and I just want to say thanks a lot for watching, and special thanks to my patrons. See you, bye bye.